Hello G. Hi everybody. Am I audible? All good? Let me just check and make sure. Let me just check because nobody else seems to be there right now. But yeah, definitely I'm sure that you'll be watching this afterwards. If not live, then recorded. Both are fine with me. Magic of Money is there. Hi Magic of Money. How are you? You are there. Thank you. God bless you. God bless you, child. God bless you. So sweet. Great. So having fun, huh? Okay, last class, I'm sorry for that, I could not complete indefinite integration because of my bad throat. Teachers generally have this problem. I've met so many educators, so many teachers, and most of them have this problem. Superb Magic of Money from Tamil Nadu. Great. So much of teachers have this problem of throat. We don't take care of throat very well. That's one reason. But yeah, I have started to do that. I realized it after 5-6 years of teaching that yeah, Baba, you have to keep your throat and your fitness upright, just like Kalia sir, huh? Body shoddy. So I've started running, I've started doing exercises and all those things so that fitness is maintained. And for throat, I'm taking some medication, Ayurvedic medication, very bitter, man. I can't tell you how how do I gulp it down my throat, but yeah, I have to take that. Thank you Magic of Money. Yeah, so I was saying that one part, like most of the formats of indefinite integration we have studied. One format of algebraics is remaining, and then we'll be moving to the partial fraction, by parts, and the trigonometric formats. But today I'll make sure that we get done with integration. Okay, one more thing which I want to tell you all. If anybody listens to this later also, we are planning. I'm not saying there is any tentative date, but we are planning that we come up with kind of a crash course. So you tell us, what are your thoughts on this? Crash course means like we'll be studying. It's not that we'll be studying very fast or not studying entire topic. We'll be studying faster, but yeah, we'll try to cover up everything, all the major topics of physics, chemistry and maths in 2 or 2.5 months, max 2 months, so that it can benefit all of you. I'll mark in my maths exam. No worries, Magic of Money. It's okay. It's not a problem. If you got less marks or if you failed in maths, failure is never a problem. In fact, I would say that failure, always pushes you a bit harder. Don't take failure lightly. That can be a problem. But yeah, failure is not a problem. I'll tell you one very simple thing. What happened with me in class 12th, I was very good student in class 11th. I was in the top batches. I'm from Kota, so there I was a very good student. In 12th, all of a sudden this food pipe where the food goes down, this started to there started to occur a problem, and I was not able to gulp down the food. Even if I'm gulping down, I'll puke it out after some time or so, and I was very, very bad condition in the starting 3-4 months. I started 12, but after 1 month only, I started falling sick very badly, and that made me go into severe trauma, that what I'm going to do now. There is no life, there is nothing to do in life now. My life is ruined. I'm not going to get into IT. I'm not going to do anything. I'm not even going to be able to pass my 12th class. That was my condition. For 1 complete month, they inserted a rice tube inside my nose, which used to go till my stomach, and they used to give me food in form of molten form. They used to give me food in in juicy form or something. Because solid food I was not able to gulp down only. Great, Kritik, great to know that. many Tamil Nadu students I'm getting. I'm very glad because of that. So much love for Tamil Nadu. So after that, what happened? That my entire 12th went bad. I was in senior trauma. In 12th class, my father said, don't give exams or do something. But then what I did, I was totally failed. I was totally failed. All the tests of my coaching, everywhere I was failing, badly. But my sister, she said that, see, it's just one chance. It's just one chance. Either you can keep this failure and behave like a failure, or you can stand up again, take your time, get well again. I got well. I got discharged out of hospital in November or December, I think. I remember. Right, in December, for complete 3-4 months I was hospitalized. And then I realized that no, now nothing can be done. But my sister told me that you give 12th, okay, and you repeat. See, there was one chance that I could just keep the failure and work according to it. I could ask my father that get me into any college, whatever I'm getting. If not, then I'll do my 12th, I'll choose some other career. But engineering was my thing that I wanted to do it. So I secured good marks in 12th, which allowed me to, at that time AIEEE used to happen. Not even IIT Advanced, JEE Mains, this was not the scene. AIEEE used to happen. Okay, then again I passed my 12th, did not, I appeared for EEE, but I could not clear because entire 12th was buckled up. And then again, one more chance I gave myself for the exam, and then I did not clear it with very good marks. I would not lie, but yeah, I cleared. But see, if I took the failure upon me, if I adjusted according to it, if I, seek myself as a failure, then the life was ruined anyway. But you have to stand back. It's okay. If you fail, there is no problem in that. There is no problem at all in that. Maths is totally dependent on you, sir. Please don't give up on us. I won't give up, Harish. Why would I give up? You're from which college? I'll tell you. Okay, don't worry. Let's focus on the chapter now. See, integration, it's all about formats. So if you have not watched the first part of this chapter, please watch it. Entire integration, it's not difficult at all. Memorization and formats. You have to mug up the formats, you have to mug up the standard integrals, then only you can proceed. Then only you can proceed. Otherwise, you can not proceed. Okay, so revise the first part, then only we can go ahead. Sir, will the chapter be completed today? Yes, the chapter will be completed today. Pay attention. Please listen carefully. Very specific things are there in integration. There is nothing beyond this. I can guarantee you that. If you are thinking, sir, this is there in NCERT also, I know. Not everything is there in NCERT first of all. Very few things, very few formats are there. So here, the specific formats, if you can remember, if you can practice these, then nobody can stop you in integration. Otherwise, integration is always going to be a scary chapter for you. Definitely, you won't be able to do differential equations again. You won't be able to do. So be specific with the formats. Please, please learn the formats very carefully. Practice them with some questions. Some questions you'll get in the PDF. Some questions you have in your books and all. Okay. Now, so 4 formats, algebraic formats we learned. Linear by quadratic, constant by quadratic, quadratic upon quadratic, degree 3 upon degree 2 or higher degree upon lower degree. 3-4 formats we have already studied. Now these type of formats where we do not have anything like the previous formats. Okay. Okay, Madurai people, great. The best South Indian food, the best Tamil Nadu cuisine I've ate is in Madurai only. Not even Salem, Madurai, I would say. Yeah, restaurants are better, but Madurai meals are superb. Okay, now see, 3 formats. Remember them as it is. If you see a linear inside the root, and outside there can be anything, outside there can be a linear or a quadratic. But remember, if you see linear inside the square root, then what you have to do is take your linear equal to t square. Substitute the linear as t square. For example, over here, the linear function is inside the root. Whenever linear function is inside the root. Now over here phi x, what do we mean by phi x? Phi x is nothing, either a constant or it is a linear function. Okay, either a constant or it's a linear function, linear polynomial only. Okay, linear function divided by, here it can be quadratic, this factor can be quadratic, this factor can be quadratic, but quadratic is not inside the root. Linear is inside the root. Whenever you see linear inside the root in denominator, simply go ahead and put your linear equal to t square. Magic will happen. Magic will happen when you do that. I'll show you the magic in the questions, but magic will happen when you do this. Second thing, whenever you see a quadratic inside the root and outside there is a linear or linear to the power something. Okay, both the things. Main focus should be on what is inside the root. Inside the root there is a quadratic. Right, there is a quadratic. Inside the root, if you see a quadratic, simply put your linear equal to 1 by t. Remember this. Put your linear, what is the linear? Px plus q over here, equal to 1 by t. Again, magic will happen. This is the strategy. This is the working strategy for this question. Remember that. How to work up for this question? This is the specific. If you do not follow this, if you try to make a perfect square over, a perfect square over here, or complete the square over here, or try anything else, you might reach to the solution, but it will take a loads of more time than this. Okay, then linear. In the numerator, either we have constant or we have linear. Doesn't matter. Both will work. Now, third form. If you have pure quadratic, means which does not involve x term. There is no x term. Only x square term and the constant. If you have both pure quadratics, this is also pure quadratic, this is also pure quadratic. If you have pure quadratic and pure quadratic is inside root also, this is also pure quadratic and one pure quadratic is inside root. Two pure quadratics, one inside the root. In this case, simple substitution, just put your x is equal to 1 by t. That's it. This should be your first step. Most of the time, my dear students, the problem is of first step only. In integration, many times you'll face this, that integration we cannot start. How will we reach to the problem? We are not even able to think of the first step. Reason is working strategy is very specific according to the formats. It's all about formats in entire integration chapter. Remember that. Formats, right? Type of problems, how many ever type of problems you keep on practicing, every problem you'll realize that it's about the format. Arey, we forgot the format. That's why we are getting stuck. Okay. Sorry? Any problem? Harish and Tribhuj. Oh my god, don't talk there. Pay attention. You guys are so fond of talking to each other, right? Friendship is the main target right now. The actual friendship, I must tell you, actually starts in college. I'm sure it is very good luck if you find any friends from your school. Very few friends will stay from school, but in college. So main target should be to get a good college so that we can get good friends, good exposure. Bad college, bad exposure, bad friends. All rowdy only. Okay. Okay, this thing only is written over here. First part, in the first part, you have to take linear as t square. If inside the root you have linear. If inside the root you have quadratic, then you will take linear as 1 by t. Remember this. If inside the root you have pure quadratic, that means no x ka term. Right? Outside also pure quadratic. In that case, just put your x is equal to 1 by t. Now, how is this going to help? See, it will convert the problem into something that you know. That's the main target. What is inside the root over here? What is inside the root over here? Come on, tell me, what should I do? What should I do? What should be my substitution? If you like, please try to solve this problem with any other method also, if you want to. Not a problem. Inside the root I have linear. Simple. Linear as t square. That should be my first step. After that, I'll think about the problem. Okay. Now what? How will this help? How will the magic happen actually? Tell sir, you are from which state? I told, right? I am from Kota. but I stayed in Chennai for from 2009 to 18, almost 9 to 10 years. Okay, so a little bit part from Tamil Nadu also. I'm not that good at Tamil. My Tamil is very bad. I can understand. I watch Tamil movies only, but yeah. Okay, x plus 2 upon this. Now, how is this substitution going to help us? You tell me. When I differentiate on both the sides, what will happen? What will happen? I'll get dx is equal to 2t dt. Will I get this? Dx is equal to 2t dt will happen. Okay, this is one thing. How is this going to help you? Now dx I can put as 2t dt. Okay, dx I can put as 2t dt. Let's look at this integral. X plus 2. Okay, dx, instead of dx I'm putting 2t dt. Achha, 2 we can take out only, na? So 2 let's put over here t dt. Okay, now over here x square plus 3x plus 3. Can we substitute using t only? Now we want everything in t. Actually, I shouldn't have written x plus 2 also. Instead of x plus 2, what can we write? X plus 2, that means t square plus 1. X plus 1 is t square. X plus 2 will be t square plus 1. So t square plus 1 will be better. Now, because dt is there, so I'll have to put everything in terms of dt. What will this become? This thing. T square minus 1. What is the value? See, one way is that you can directly whole square both the sides and then create x square plus 3x plus 3. That way also you can proceed. Anna pesaranga Tamil. No, don't make me speak anything in Tamil. You guys will, fall from your chairs or beds while laughing. I don't want to do that. I've told, right? Na Tamil pesra ni siripya. I'm not sure how to use the conjunction there. X square plus 3x plus 3. Okay, substitute this. T square minus 1 plus 3t square. Oh, sorry. T square minus 1 whole square. T square minus 1 will be x. So 3t square minus 1. 3 into t square minus 1 plus 3. Correct? Let's solve this. T to the power 4 plus 1 minus 2t square plus 3t square minus 3 plus 3. So I think minus 3 plus 3 gone, minus 2t square plus 3t, okay, plus 3t square this is. So plus t square, t to the power 4 plus t square plus 1 multiplied with what? This is our t square only. So t square under root will become t only. Correct? Anything wrong here? Anything difficult to understand? No, right? So this and this got cancelled. Very good. See, magic started happening, no? Magic started happening. Now this is 2 integral of t square plus 1 divided by t to the power 4 plus t square plus 1. And now you know how to proceed. Which format is this? Revise the last lecture. Putting quadratic as t wrong. Quadratic if you'll put as t, how? 2x plus 3. If the derivative of this was there in the numerator, then we could put quadratic as t. But here it will not help, right? When do we put quadratic as t? If the derivative of that quadratic is there in the numerator, then only. Otherwise there is no use. Otherwise that will not help us. Here, now we know. Which format is this? Format number 4. What was format number 4? Even powers. So what do we do now? Divide by t square. Divide by t square. That's it. Correct? Divide by t square. So numerator will become 1 plus 1 by t square. Denominator will become t square plus 1 by t square plus 1. That's it. T got cancelled only. This we know how to solve. Right? This one we know how to solve. So remember, if you remember the last class, I'll solve it for you over here. Let me remove this. Okay, wait. I'll write this once again. 1 plus 1 by t, na? And 2 times the integral of 1 plus 1 by t upon t square plus 1 by t square. What was there? Plus 1. Plus 1 is there. Where did this come from? Okay, this thing, you know, this is wait, 1 plus 1 by t only. 1 plus 1 by t square it is. 1 plus 1 by t square it is. Okay. This form we know. This into dt. Why do I forget dt? This into dt. Correct? This form we know how to solve from method number 1. What do? We'll put this t square plus 1 by t square. We'll write t square plus 1 by t square in the terms of this. Correct? 1 minus this will become, so 2 integral of 1 plus 1 by t square. Okay. Now what we'll write? This we'll write 1 minus 1 by t square. 1 minus 1 by t square whole square. Sorry, 1 minus 1 by t. 1 minus 1 by t whole square minus, so we'll have, this plus 2 and plus 1. This plus 2 and plus 1 will be equal to this. So we'll have plus 3. 1 minus 1 by t whole square plus 2 will give us this only. And plus 2 plus 1 will make it 3, and dt is still there. Correct? Correct? Now solve this. So this will be 2 t square I think will get cancelled. 1 plus t square will come in the numerator with dt. Denominator, what will denominator become? T minus 1 by t. So this will become, okay, t square getting cancelled. T minus 1 whole square. T square will get cancelled. Plus 3t square will also come. Plus 3t square will also come. Wait. T square and plus 3t square. What will this become? 1 plus t square will come in the numerator, and we are doing something wrong here. No, correct only. 1 minus 1 by t whole square plus 3. Correct. Okay, 1 minus t whole square will come over here. Correct. 1 minus t whole square will come over here, plus 3t will come over here. Wait, let me solve it in this thing. 1 minus 1 by t. So this will become t minus 1 whole square by t square plus 3. So that means t square plus 1 minus 2t plus 3t square. Okay, 4t square will come. All right. So this thing, instead of writing this thing directly, this will become 2 by root 3. 1, that format will become, right? dt by a square plus b, a square plus x square will come. So that will be a into tan inverse of 1 minus t minus 1 by t, t minus 1 by t. When you'll put this equal to u, put this equal to some u, 1 minus 1 by t equal to some u, right? So minus t square minus 1 by t, plus 1 by t square will be your du. That's all, right? Last class. So directly I'm writing, this will become 2 by root 3 tan inverse of t minus 1 by t divided by root 3. That's it. Root 3, because plus 3 we'll have to write as root 3 whole square, a square plus b square. We'll have a square plus b square now. Okay. Plus c. So remember the previous formats. Here I'm doing, but we cannot do everywhere. Right? Remember the previous formats. This is nothing after this. Actually, we have done, after this step, we have just used format number 4, where we divide numerator and denominator both by t square. Okay, numerator even power, denominator even power, divide by x square. That's it. That's what we have done. Okay. Let's move on to this. Here what should be the substitution? Inside the square, what do we have? Do we have pure quadratics both outside and inside? Is this the second point or the first point? This is the second point actually, not the first point. Correct? This is the second point actually, not the first point. Second point, not the third point. I'm saying third point mein what was written? Outside pure quadratic, inside the root also pure quadratic. Here quadratic is there inside the root, outside there is no pure quadratic. Okay, so we'll use the second format. We'll put this equal to 1 by t. That means our linear equal to 1 by t. We'll put px plus q equal to 1 by t. So x minus 2 we'll put as 1 by t. Differentiate both sides. So dx will be equal to minus 1 by t square. Sorry, yeah, minus 1 by t square dt. That will be your dx. Now substitute it over there. So integral will become dx is minus 1 by t square dt. Let me put in brackets. What will be x minus 2? X minus 2 is 1 by t only. What is root of x square minus 4 now? What will be root of x square minus 4? Simply substitute. Okay, simply substitute as it is. X minus 2 is your 1 by t. So x square minus 4. That means 1 by t plus 2 whole square minus 4. Solve it over here. 1 by t plus 2 whole square minus 4. So it will be 1 by t square plus 4 plus 4t, 4 by t, sorry, plus 4 by t minus 4. Correct? This thing will come. So put it over here as it is. 1 by t square plus 4 by t, and dt is already there. Correct? Now how did it help us? See, if you take the LCM over here, t square will be the LCM. Correct? So t square will come out as t only. T square will come out as t only. What will we have in the numerator? In the numerator we have 1 by t square. In the denominator t will come out. So t into 1 by t square only will be formed. Inside what will remain? Inside t plus 4 will remain. Correct? 4t plus 1 will remain. 4t plus 1. 4t plus 1 will remain. T square and t square will get cancelled over here. What do we have? We have negative of dt by square root of 4t plus 1. Do we know this? Correct? Simple. So square 1 by square root x. Instead of t we have 4t. Do not forget to divide by coefficient of t. Right? If we know the integral of x, we know the integral of ax plus b also. In integral of ax plus b, we'll just divide by the coefficient of x. That's what we are supposed to do. So what will be this? This will become minus 1 by root x. So minus 2 root x minus 2 root, instead of x we have 4t plus 1, divide by 4, coefficient of t, divide by 4. So it will become minus 1 by 2 square root of 4t plus 1. Now substitute your t again. T is from here. You'll have to substitute your t from here. So it will become x minus 1 by 2 into x plus 2 upon x minus 2. Right? X plus 2 upon x minus 2. When you'll find the value of t, when you'll put the value of t from here, x plus 2 upon x minus 2 will come. Okay? Plus c, obviously. So remember these substitutions as it is. They'll help you a lot. Okay. Is this same? Have we learned this? Have we learned this? Did we have numerator? What was the numerator? Phi x was either constant or it was a linear. Here we don't have both. It's not a constant also, it's not linear also. Power is 1 by 2. Special case. Generally you will have all three cases only. Sometimes if you see something like this, try to deduce it into the forms that we have learned. The three, in format 5, the three forms that we have learned. Minus, we can put 1 minus 1 by t as u. Where? Yeah, 1 minus 1 by t as u. That's what, bro. Bro, my god. Okay, now here what can we do? Think about it. Acha, what is, can I write root x as x by root x? Any problem? When I'll rationalize this, when I'll multiply root x in the numerator and denominator, numerator will become root x, denominator will be x again, x will get cancelled, same thing. So root of x plus 1, can I write it as x plus 1 upon root of x plus 1? Any problem? No. So this will become root of x plus 1 divided by x plus 2 into root of x plus 1 into root of x plus 3. So inside root we'll have x plus 1 and x plus 3 dx. Correct? Now this is quadratic inside the root. This is what? This is quadratic inside the root. So this form we know. Wait. I wrote this is wrong. No? This will be x plus 1 only. X plus 1 only. So x plus 1 divided by x plus 2 into square root of x square plus 4x plus 3. Inside the root we have quadratic. So what we'll do? We'll put linear as 1 by t. Put x equal to 1 by t. Put x equal to 1 by t and proceed. Not x. Put x plus 2 equal to 1 by t. Linear as 1 by t. Put your linear as 1 by t. Sorry, my bad. So when we'll put x plus 2 as 1 by t, what will happen? Dx will be equal to minus 1 by t square. This dx will be equal to minus 1 by t square. Here there was a dx. Okay, now x plus 2 is 1 by t. So what will this become? This will become 1 by t minus 1. 1 by t minus 2 plus 1. So 1 by t minus 1. Numerator will be 1 by t minus 1. Denominator x plus 2 is 1 by t only. Inside root 1 by t square. 1 by t square minus 1. Square both the sides. So 1 by t square minus 1. X plus 2 whole square, x square plus 4 plus 4x. Correct? So 1 by t square minus 1. Here we will have 1 by t square minus 1. Now you know how to proceed. Correct? Did we have anything else? Acha, x square, x plus 2, correct, 1 by t, not a problem. 1 by t minus 1. Acha, there will be one more t square over here. Correct, there will be one more t square over here. Because of this, dx is equal to 1 by t square. No? So 1 by t square. That t square we forgot. And obviously a minus outside. So that will cancel this. What will this form? This will form integral of 1 minus t from the numerator, and here we'll have t into square root of 1 minus t square and dt. Put this inside. Do we know this? This we know how to form. This we know how to solve. Instead of writing a minus over here, what you can do is integral of t minus 1 also you can do, and t into square root of 1 minus t square you can write. Now you'll form two integrals if you want. Sorry. Right? T upon square root of 1 minus t into square root of 1 minus t square, and 1 upon t into this will just form like this. So integral of t upon this, that means 1 upon, or sorry, dt upon square root of 1 minus t square minus dt upon t into square root of 1 minus t square. Integral 1 you know already, sine inverse of t. This will become sine inverse of t. Second one, you know how to solve. Just put your t is equal to 1 by u, or 1 by t is equal to u. Okay, 1 by t equal to u. If you'll put, you'll be able to solve. Here put 1 by t equal to u. That's it. Okay, and proceed. If there is, it's written, yeah, first integral, second integral, put t equal to 1 by u. As soon as you put it, dt will become minus 1 by u square. Here in the numerator you will have u, and denominator will become u square minus 1 as it is, without any problem. Okay, and this one you know, log of a plus root of x. Now come upon to this. Dx upon x square plus x plus 1 whole square. First of all, we'll look at the right side, left side. Right side, so we'll be able to deduce if we are able to find the integral. Acha, square of quadratic. What thoughts come in your mind? Sir, completion of square. One thing can be, sir, we can complete the square and then we can proceed. That can be one thought. Any other substitution which you can think of? No. So completing the square is the only go ahead method. Now, as soon as you see this, what can come into your mind? Standard integrals will come into your mind. But we don't have anything like this. Quadratic square. Even if we complete the square, even if we, what comes into your mind? Magic of Moni says, sir, t comes in my mind. T sapdava. Okay. Completing the square should come into your mind. Okay, completing the square should come into your mind. X square plus x plus 1, try to write it as a square in the form of two squares. So, divide by the coefficient. 1 by 2 will come here. 1 by 2 whole square, 1 by 4 plus 1, 1 by 4 minus 1 we'll have to do. So minus 3, plus root 3 by 2. 3 by 2 will come, 3 by 4 will come. We can write it as root 3 by 2 whole square. We can write it as root 3 by 2 whole square. So it will become dx by, I'm writing directly, you can use completing the square. You have learned in the last class. So it will become x plus half whole square first of all. Okay, x plus half whole square, because coefficient of x is 1, so half of it. Now square of coefficient of x will be added to this. So this will become added and subtracted. Added will make it whole square, x plus 1 by 2 whole square. Subtracted, so 1 minus 1 by 4. 3 by 4, positive 3 by 4, root 3 by 2. So here we'll have plus root 3 by 2 whole square and square on this complete thing. This should be the first step which should come into your mind as soon as you see this problem. Okay, because this format we have not learned. No? Square of quadratic, where did we learn? So how will we proceed? We'll proceed by completing the square. That we know. Now can you think of something? Now you know x plus 1 by 2 ka derivative is sitting in the numerator. X plus 1 by 2 derivative dx only. Correct? That is there in the numerator. So obviously, very obvious substitution will come into your mind. That, sir, put x plus 1 by 2 as t. Put x plus 1 by 2 equal to t. Correct? So that your dx become equal to dt. Dx will become dt, and this integral will now become dt divided by, this is t, so t square plus root 3 by 2 whole square ka square. Now something is going to help you. See, remember I told you about substitutions. We don't know this format. we know 1 by x square plus a square, but we don't know this format, 1 by x square plus a square whole square. No, we don't know this format. So but remember, whenever something like this comes, I told you about substitutions. Whenever you see a square plus x square and you are not able to write it into any specific format, so here you need to do a valid substitution. Either you put x is equal to a tan theta or you put x is equal to a cot theta. In these cases, here you know 1 by x square plus a square is happening, we can get 10. That way also you can remember, right? So here you need to make a substitution. You'll have to put your t as root 3 by 2. What is a? Put x as a tan theta. Here we don't have x, here we have t. Correct? A square plus b square, a square plus x square form is there. So x square plus a square form is there. X you'll have to put as a tan theta. A tan theta. X you have to put as a tan theta. But here there is no x. Here we have t. So that means t you'll have to put as what is a? X square plus a square. A is root 3 by 2. So root 3 by 2 tan theta. Okay. Put it like this. Remember this. Whenever this type of situation occurs, that you know the format, but there is a slight change in the format. So remember those substitutions. A square plus x square. A square minus x square. Correct? Those substitutions you'll have to remember and they'll help you in many of the problems. Otherwise, going ahead with this will again can be multiple steps. You can open it up and then solve it by the use of 1 by quadratic and all. But substitution will make it much simpler. See, t equal to root 3 by 2 tan theta if you can directly put. Okay. Now how will it help? Differentiate both sides. So your dt will become very simple. Tan theta derivative we know, sec square theta. So this will become root 3 by 2 sec square d theta. Root 3 by 2 sec square theta d theta. Yeah. Okay. It is helping there. Now, but sir, theta has arrived. How to move ahead with that? We know dx dt also we could do, but theta has arrived over here. Now how to proceed? Okay, no problem. So what is your differential becoming? Dt is your root 3 by 2 sec square theta. So put it like this. This thing will become dt as root 3 by 2. Root 3 by 2 I'm writing outside. Root 3 by 2. We can write outside. Sec square theta d theta. Here what will happen? T is, what is t? T we have put as root 3 by 2 tan theta. So denominator will become root 3 by 4 whole square plus root 3 by 2. So root 3 by 4 whole square will come out and 1 plus tan square theta sec to the power 4 theta. We'll have sec to the power 4 theta. Root 3 by 2 whole square will come out and we'll have sec to the power 4 theta. That is how it will help. Very good problem. Please pay attention at this problem. Solve this once on your own. Multiple substitutions are happening and majorly this valid substitutions are also taking place over here. So that's why. Okay. So root 3 by 2 and here 3 by 4. What will you have? 3 root 3 by root 3 by 2 divided by 9 by 16. Okay, let's root 3 to the 3 by 2 to the power 4 it will happen, right? 9 by 16. Root 3 by 2 to the power 4 will happen here. Correct? Did we do it correct? Root 3 by 2 and root 3 by 2 taken out. Here we had t square root 3 by 2 a. Okay, 1 plus sec square theta. Sorry, 3 by 2 will come. Wait, 3 by 2 will come. Here 3 by 2 will come, right? 3 by 2 whole square and sec to the power 4 theta will come. Correct? 3 by 2 whole square will come. So that will become 9 by 16 over here. We'll have root 3 by 2 divided by 9 by 16 integral of, this will cancel on 1 by sec square theta d theta, which we'll write as 8 root 3 by 9 integral of cos square theta d theta. Do we know the integral of cos theta? Cos square theta? We don't know. Cos square theta direct integral, we don't know. We have not learned that. So whenever this happens, remember what we need to do? We need to break it into half angles. So 1 plus cos theta by 2 will write cos square theta will become 1 plus cos 2 theta by 2. Right? Write it like this. Integral of 1 plus cos 2 theta by 2 d theta. That you'll have to think of. So totally it will become 8 root 3 will become 4 root 3 by 9 and 1 plus cos 2 theta d theta. Wait, we'll have 4 root 3 by 9 integral of 1 plus cos 2 theta d theta. This we know how to solve. Correct? This will become 4 root 3 by 9. 1 will become theta and this will become sin 2 theta by 2. Integration of cos 2 theta and dividing by the coefficient of theta, right? Linear coefficient only. So 4 root 3 by 9 theta plus sin 2 theta by 2. That will be the answer. Now we'll substitute theta and the other things. Okay, what did we take? Theta as sorry, not theta, we took t as root 3 by 2 tan theta. So theta will become tan inverse of 2 by root 3 into tan inverse of t, right? So it will become wait, I'll write 4 root 3 by 9. This will become tan inverse of 2 by root 3 into tan inverse of t. So this total thing will become 2x plus 1. Instead of theta, we should write tan inverse of, what was our, what did we take? X as. So here x is t minus 1 by 2. Achha, total thing will become tan inverse of 2x plus 3 by 2. Oh sorry, root 3. 2x plus 1 by root 3. Here we'll have this. And plus sin 2 theta by 2, so it will become root 3 do the substitutions once on your own. Do the substitutions once on your own. Just substituting theta as t and then x. That's it. So this will be your final answer. I think we can compare now. Can we? No. 2x plus 1 by root 3. This is correct. 2x plus 1 upon x square plus x plus 1. 2x plus 1 upon x square plus x plus 1 kahan? Achha, 1 by root 3 if we take common. 1 by 3 will come out common. No problem. This will become 4x square plus 1 plus 2 plus 4x. Still not getting the same form, right? 2x plus 1 by root 3 is obtained. So a is definitely 1. A is not 1. A is not 1. Achha, 4 root 3 by 9 also we'll have to multiply. So this, let me write it over here. 4 root 3 by 9 tan inverse of 2x plus 1 by root 3 we'll have here. Plus root 3, 3. Okay, so and 3 by 9, 1 by 3. 1 by 3 into, we'll have 1 by 3 into numerator will be 2x plus 1. Denominator, something's wrong. 3 plus 2x plus 1, how are we getting in that form? Achha, 2 will get, so 4 will come out common. Wait, 2x square plus x plus 1. Now we are getting. Wait. Still 2x square. क्या गलत कर दिया? What did we do wrong? 4 root 3 into root 3, no problem, 3, 3, 1 by 9. Acha, 1 by, here, from here we took 4 common, and that 4 will cancel this. In that case, yes, this will become x square plus x plus 1. X square plus x plus 1. Sorry, calculation mistake. Now, so b becomes, what did your b become? B becomes 1 by 3. A becomes 4 root 3 by 9. Okay, so you can find 9. What did we what do we need to find? 9 into root 3 a plus b. So 9 into root 3 into 4 root 3 by 9 plus b, which is 1 by 3. What is this? 3, 3, 1 by 3, 1 by 3, 4 by 3 plus 1 by 3, 5 by 3, 3 3s are 9. It will come out to be 15. 15 will be the answer. कैसे हुआ? क्या हुआ? What happened? How are you able to type Hindi? Do you have Hindi keyboard? Or you're using the phone? Yeah, there can be two possibilities. क्या कैसे हुआ? कब हुआ? कुछ हुआ? Which thing are you asking about, bete? Watch this once again. Go through this. Okay. Main thing is that over here, how to start that you know. Complete the square. That should be the strategy. Then you came to know that x plus 2 ka derivative is sitting here, so substitute that. Then you'll have to come in theta because still whole square is there. So valid substitutions which I taught in the previous class, that you'll have to use. Whenever you see a square plus x square, put x is equal to a tan theta. That we used. Then we came to this. In theta, cos square theta also we don't know. Direct integral we don't know. That's why we converted into half angle. 1 plus cos 2 theta by 2. Then we proceeded ahead and then nothing else, right? Then just substitutions of theta as t and t as x. Okay. Now let's come to partial fraction. Partial fraction is used, see, we have learned one format where if we have higher degree in the numerator and lower degree in the denominator, what we'll do, we'll divide the two polynomials. Suppose we have cubic in the numerator and denominator we have quadratic, we'll divide the polynomial and proceed. Okay, higher degree in the numerator, denominator was lower degree. Now, partial fraction mostly, see, the questions where partial fraction is supposed to be applied might be done or be solved by the other formats also. Linear by quadratic, if it is there, then it's not necessary that you apply partial fraction only. But suppose you have quadratic by cubic, then what will you do? You cannot divide a quadratic by cubic. You can divide a cubic by quadratic, no problem. But how will you divide a quadratic by cubic? In that case, we'll have to use partial fractions. Okay, if the degree of your, so improper fraction and proper fraction you must have studied in your class 2nd or 3rd, right? Improper fraction means numerator is greater, denominator is smaller. So improper fraction. Proper fraction means 1 by 3, 1 by 2, 2 by 3, 2 by 4, 2 by 5, right? Numerator is smaller, denominator is greater. So partial fraction technique we'll use when your degree of numerator is less than the degree of denominator. Linear by quadratic, it can be used. Quadratic by cubic, it can be used. Linear by quadratic, most specifically, it is going to help you. So partial fraction give us the way to represent proper fractions into sum of difference of simple fractions. Specific technique. Whenever you see something like this, okay, denominator you have, you know you are going to form a quadratic. Numerator is linear. Okay. Now, one way of solving this is, if the derivative of quadratic is sitting in the numerator, then you can put the quadratic as t and can proceed. But if it's not the case, then what will you do? Right? If the derivative of your quadratic function or polynomial is sitting in the numerator, suppose we have x square plus 2x plus 3 in the denominator, and in numerator we have x plus 2. Then you can simply put x square plus 2x plus 3 as t and then proceed. Not a problem. You'll reach to a solution. But if it's not the case, if it's some other polynomial if it's some other linear polynomial in the numerator, then what will you do? So in that case, remember, you'll have to break your fraction which is improper, which is Yes, which is proper fraction. Which is proper fraction, not improper fraction. Right? In that case, what will you do? You'll write it as a by this one. Both are linear. So a by x minus a1 plus b by x minus a2. And then you'll find a and b, and then you'll proceed. Remember this technique, very useful sometimes. Right? Very useful sometimes. So proper fraction means numerator's degree is lesser, denominator's degree is higher. In that case, break your fraction in these terms, and your derivative of denominator is not there in the numerator also. Right? These two specific cases. So break it like this. If you have such a case, now remember here what will happen? A by, so here the substitution will change a little bit. X minus 1 as it is below A plus b by x minus 1 whole square. If it had cube, then we'll add c by x minus 1 whole cube also, but I don't think that much will come if it's square. So first write a by x minus 1, a by x minus 1, x minus a1 plus b by x minus a1 whole square plus c by x minus a2. Break it like this. I'll tell you how it will help definitely, but first note this down. Okay, then we have quadratic and linear. So first, linear by quadratic. This is constant by linear, constant by quadratic, pure quadratic, constant by linear. Here no problem. Here we have not a pure, this is not a pure quadratic. We have x term also over here. So linear by this quadratic as it is. Okay, ax square plus bx plus c plus, now b, this should be capital B. Okay, plus c by this linear as it is, plus c by this linear. Okay, remember this. Both are squared. Quadratic is also squared, linear is also squared. Here there is no square on quadratic, so we use this. In this case, first take ax plus b, linear, capital B, linear divided by quadratic without the square. So ax plus b, ax square plus bx plus c. Then another linear, one more linear. So cx plus d divided by square of this quadratic. That means ax square plus bx plus c whole square. Okay. Plus then e and f for these two, plus e by linear only x minus a1 plus f by square of linear x minus a2 square. Okay. If we have power 2, then first the without power factor, then the power factor. Okay. In this case also we had power on x minus a1 also. So e by x minus 1 first, then f by x minus a1 whole square. This is a1. Okay, this is written in better handwriting, don't worry about it. So remember how to break a proper fraction into some simpler fractions. Proper fraction will create a problem if derivative is not sitting in the numerator. That can be the case. Other case, if we have improper fraction means degree of numerator is greater than the denominator. Then we know format number 5 will format number 3, not 5, format number 3, where we'll divide the numerator by denominator. If the degree of numerator is higher than the denominator, then just simply divide the numerator by denominator and you can proceed. The working strategy will help you. Now let's look how partial fractions can help us sometimes. For example, here if you will see x plus 2 into x plus 3. Acha, x square plus 5x plus 6. But derivative of x square plus 5x plus 6 is sitting in the numerator kya? No. Correct. So it's not going to help us. It's not, substitution of quadratic as t is not going to help us. What will help us in this case? In this case, partial fraction only will help us. Okay. In these type of cases, partial fraction only will help us. Now break this 2x plus 1 by x plus 2 into x plus 3. Both are linear. Dx. Both are linear. So a by x plus 2 plus b by x plus 3. We'll simply break it like this. And now we'll find a and b. So this same thing, actually, instead of dx and integral, I should just use this much. This thing we are breaking, okay? This thing we are breaking in simpler fractions. And this we know, right? Ln 1 by x, ln x, right? 1 by linear, ln x by coefficient of x. This we know how to do that. If we can find a and b, problem will be easier, much easier. How difficult it can be to find a and b? Will it be difficult? See, take the LCM. So 2x plus 1 is equal to a into x plus 3 will come, plus b into x plus 2 will come. What will happen to the denominators? X plus 2 into x plus 3 will be this side on the denominator. X plus 2 into x plus 3 is this side also in the denominator. Both will get cancelled. Now directly, either you, if you want, you can compare the coefficients. For example, I can take 2 is equal to a plus b. It will give you two equations in a and b. And 1 is equal to 3a plus 2b. Either you can solve these two equations, or one more approach you can use, that directly put any value. Both sides are equal. For any value of x, they'll be equal. Now, if you put, how will it help you? If you put x as minus 2, let's say. If you put x as minus 2, put x as minus 2. Put x is equal to minus 2. Minus 4 plus 1. So minus 4 plus 1, directly I am writing. Minus 3 will come on this side. What will come on the other side? This will become 0. Minus 2 plus 2, 0. A into x plus 3. That means a into minus 2 plus 3. That means 1. So directly we are getting a equal to minus 3. Now put x is equal to minus 3. Directly you will get the value. If you put x is equal to minus 3, this thing will become 0. Minus 6 plus 1. That means minus 5 will be equal to minus 3 plus 2, minus 1, minus b. So that means your b will come out to be equal to 5. Correct? Now what? Your integral of 2x plus 1 divided by x plus 2 into x plus 3 dx can be written as integral of a by, so minus 3 will come out, minus 3 by minus 3 upon x plus 2. Correct? So dx upon x plus 2 plus b upon x plus 3. So 5 upon x plus 3. So plus 5 integral of dx upon x plus 3. Will it be difficult to solve? This will become minus 3 ln of x plus 2, both by 1. So coefficient of x is 1. This will become minus 3 ln of x plus 2. This will become plus 5 ln of x plus 3. Without any problem, you'll be able to do this. Otherwise, it will take much more time. Partial fractions are helpful. That's why they are being taught. Plus c, obviously. Okay, let's see one more application. X cube plus 1. Do we know any direct integral of this? X square plus a square, if it was written, then we could do something. But this is x cube plus 1. This is x cube plus 1. What will we do? How will we proceed? We'll break it into a linear and a quadratic. That we know, right? This can be broken into a linear and a quadratic. So 1 by x cube plus 1 can be written as 1 by x plus 1 into x square plus 1 minus x. X square minus x plus 1. That we can do. Now this we can break. This we can break as 1 by linear. 1 by linear plus linear by quadratic. A by linear, that means a by x plus 1 plus linear, that means bx plus c by this quadratic, which is x square minus x plus 1. Correcting? So if we compare, left side we'll just have 1, Right side we'll have a into x square minus x plus 1 plus bx plus c multiplied with x plus 1. You can compare a plus b. If you compare coefficient of x square, a plus b will become 0 because there is no x square over here. Correct? A plus b directly will become 0. Then compare linear. So x ka term, that is also 0, minus a and c minus a plus c. Yeah, so this side 1 and a plus c, your a plus c will come out to be, first write a plus c only, no, constant, a plus c will come out to be equal to 1, that is for sure. And your b will come out to be equal to minus a, because 0 will be equal to b plus a, so b will come out to be equal to minus of a. Now you'll be able to find all the three. Achha, b is equal to minus a is coming from here only. Wait, then we have not compared carefully. Kya? Minus a plus c minus a plus c is equal to also 0. So your b wait, let's not compare like this. Let's put something. Instead of comparing like this, it's better that we put something. Let's put x equal to minus 1. If we put x equal to minus 1, minus 1, 1 minus 1, 1 plus 1, 2 plus 1, 3, 3a will come out to be equal to 1. So a will come out to be equal to 1 by 3. In that way, comparing the coefficient, mistakes can happen. So it's better that you put the values, put any value. Right, a equal, if you put x is equal to minus 1, then you'll this factor will become 0. Put x equal to minus 1. Right, put x equal to minus 1. So your a becomes 1 by 3. Now if you want, you can compare the coefficients. You know that your a plus b is equal to 0. So your b will come out to be minus 1 by 3. Right, that way also you can do. And for c, you know, a plus c was equal to 1, a plus c was equal to 1. So 1 minus 1 by 3, your c will come out to be 2 by 3. 1 minus 1 by 3 so is equal to c, that means c equal to 2 by 3. We have all the three now. Correct? Now you can proceed. Now you know next steps. If the last lecture is thorough with you, now you know the next steps. Just a minute. So let's put the values. A by x plus 1, bx plus c by x square minus x plus 1. Remembering this, I should actually keep the snaps on the other sides also. So 1 by x cube plus 1, okay, a by x plus 1, let's write that. A by x plus 1, what was our a? A was 1 by 3. Minus of integral of 1 by 3, minus 1 by 3 itself, we can keep outside. Minus 1 by 3 integral of dx by x plus 1. That's not going to create any problem. Plus bx plus c. That means minus 1 by 3x plus 2 by 3. So integral of minus 1 by 3x plus 2 by 3 dx divided by what was the quadratic? Quadratic is x square minus x plus 1. So x square minus x plus 1. This we know, both of these we know. This one directly ln, right? And that one linear by quadratic. Linear by quadratic. So for linear by quadratic also, one more method you learned. If your derivative is not sitting in the numerator, you'll create the derivative. Lambda u plus lambda x plus mu wala method. Lambda into derivative of denominator plus mu, that method. Correct? That method you'll be able to use. A B was minus 1 by 3. We are putting A as minus 1 by 3 over here. So this will just be 1 by 3. Minus 1 by, I thought there also minus 1 by 3, here also minus 1 by 3, both won't be there. Try to solve it now. What will be the numerator? Minus 3x plus, so 3 will get cancelled, 3 will come out, 1 by 3 will come out, minus x plus 2, so 2 minus x or x minus 2 will be there in the numerator. X minus 2 you can keep, not a problem. X minus 2 and take minus common out. So this will become 1 by 3 log or ln of x plus 1. This is no problem, right? Plus 1 by 3 into, wait, plus this will become 1 by 3 integration of x minus 2. Minus will come here because we are taking minus common from there. So minus will come here, x minus 2 divided by x square minus x plus 1. 2x minus 1 is the derivative of this one. So what we'll have to do, we'll have to split the numerator part into the form lambda derivative of x plus mu. So I'll do it in separately for you. What you'll have to do, you'll have to write x minus 2 as lambda into 2x minus 1 plus mu. This method I'm talking about. Okay, remember this method, right? That way you'll have to proceed. So what will lambda come as? 2 lambda will be equal to 1, lambda will be equal to 1 by 2 and mu will be equal to minus 3 by 2. So here what you can do, this part let it be like this, ln of x plus 1 mod minus 1 by 3. This thing will become x minus 2, you'll write as 1 by 2 into 2x minus 1 minus 3 by 2. This way you'll have to write it, divided by x square minus x plus 1, this whole into dx. Please remember this method. I hope everybody remembers the method of linear by quadratic, even if you don't have the derivative sitting there. So create the derivative there. Okay. Now this you'll split 1 by 6 into integral of 2x minus 1 upon this minus 3 by 2 into divided by this, and here you'll have to complete the square, right? Proceed with other formats. I hope after this you can proceed, right? There is no problem. This is clear. Now here what will create? Minus 1 by 6 integral of 2x minus 1 upon x square minus x plus 1. Put x square minus x plus 1 as t and you'll have the answer. Ln of this only will come. Okay, ln of this only will come. Minus 3 by 2 into, minus 1 by 2. 1 by 3 into 3 by 2 will become minus 1 by 2 minus 1 by 2 upon this. Dx by quadratic means complete the square. That's it. Dx by quadratic means completing the square will help you there. What I'll do, one thing, I'll try to write for as far as possible minus 1 by 6, 2x minus 1 upon x square minus x plus 1 dx minus plus, so 1 by 2 integral of dx upon x square minus x plus 1. Okay. This will become, as soon as you put this as t, correct? So you have its derivative in the numerator. So dx will become dt upon this only, right? Dt upon t. That means ln of t, and t is x square minus x plus 1. So what we'll have, 1 by 3 ln of x plus 1 as it is, minus 1 by 6 ln of x square minus x plus 1 plus this on completing the square. This you'll have to do by completing the square. So minus 1 by 2 will be added and subtracted x minus 1 by 2 whole square plus root 3 by 2 whole square. This will become x minus 1 by 2 whole square plus root 3 by 2 whole square. Now you have 1 by x square plus a square format. So 1 by a, 1 by 2 into 1 by a. 1 by 2 into 1 by a, that means 2 by root 3. So it will become 1 by root 3 and tan inverse of, it will become 1 by root 3 tan inverse of x minus x by a. So x minus 1 by 2 divided by root 3 by 2. That means 2x minus 1 by root 3. Tan inverse of 2x minus 1 by root 3 plus c obviously. Okay, till the last step. Not a problem. But please remember all the formats so that you can do once on your own also. Please reach till the answer on your own. Even if I'm not reaching to the final answer, please do it once on your own. That will help you a lot in grasping the concepts. Here, quadratic divided by pure quadratic into pure quadratic. Partial fraction only can be applied. Partial fraction, you'll see that at many places it can help you. If you're not able to think of anything, if you have different powers of functions in the numerator and denominator, go with partial fraction if you are able to apply as per the denominator. So here, as per the denominator, what we'll have to do, just like linear only, right? Suppose it was linear. Suppose we had t minus 2 upon t plus 2 into t plus 1. Suppose this was nothing but t minus 2 upon t plus 2 into t plus 1. We'll break it into a by t minus a by t plus 2 plus b by t minus 1 or b by t plus 1. That's what we'll do. Here x square is there. So what's the problem? There is no problem in that. Here x square is there. Correct? What we'll do, we'll just break x square minus 2 divided by x square plus 2 into 2x square plus 1 in terms of a by, just like what, linear only. We'll treat it as linear. What's the problem? So this will become x square plus 2 in plus b by 2x square plus 1. Correct? Just a minute, please. Proceed ahead. Okay. We can treat it like this, not a problem. Simple, x square minus 2 will become equal to 2x square plus 1 into a plus b into x square plus 2. That's it. Now, if we are treating it as linear only, what would we do if it was t plus 1 into a plus b into t plus 2? What would we do? We'll take t as minus 2. Here take x square as minus 2. X square equal to minus 2, although we should not take, but here we are treating it as linear only. So what we'll do, we'll put x square, let's take x square as minus 2. Suppose if we put x square as minus 2 over here, then what will this become? Minus 2 minus 2 minus 4. This will become a minus 4 plus 1, so minus 3 times of a, and this will become 0. Correct? So a will come equal to 4 by 3. A will come equal to 4 by 3. What will b come? Put x square as minus 1 by 2. Right? Take x square as minus 1 by 2 for the second time for finding b. If we take x square as minus 1 by 2, this will become 0. Minus 1 by 2 minus 2. Minus 1 by 2 minus 2 minus 5 by 2. Correct? Minus 5 by 2 is equal to minus 1 by 2 plus 2. So 5 by 2 only. 5 by 2 b. Sorry, 3 by 2. Minus 1 by 2 plus 2. 3 by 2 b. 3 by 2 b. From here what are we getting? B. B will become minus 5 by 3. B will come out to be minus 5 by 3. Now go back to the top form. Here only we have substituted. So this integral, can I directly write? Integral in this form? Directly I am writing, no problem, right? So this will become a, that means 4 by 3. So 4 by 3 integral of 1 upon x square plus 2. 4 by 3 into integral of 1 upon x square plus 2 dx. Plus b by this. So minus 5 by 3 integral of 1 upon 2x square plus 1 dx. Both of them are standard integrals. X square plus root 2 whole square. Correct? Here you can take root 2x whole square plus 1 square. Both of them you know, a square plus b square forms. Right? What will this become? This will become 4 by 3 into 1 by root 2 tan inverse of x by root 2. This will become, you'll write it as x square plus root 2 whole square. So 4 by 3 into 1 by a, that means 1 by root 2 into tan inverse of x square plus 2. That's it. Sorry, not x square plus 2, x by root 2. X by root 2. X by a. X by root 2. Plus this will become, minus is there. So minus 5 by 3 into 1 by root 2 also you'll have to do. Root 2x you are creating, right? Root 2x you are creating. So 1 by root 2 will be multiplied. And 1 by a. A is 1 only, not a problem. So tan inverse of root 2x by 1. Not a problem, as it is. So 5 by 3 root 2 tan inverse of root 2. This complete will be your answer along with C. That's how you'll have to proceed with integration in this case. Do we know the integration of this? Directly do we know? Think about it. Check this. Do we know the direct integration of this? E to the power x minus 1. No, obviously not. There is no form. There is no standard. This is not a standard integral. But we have learned one thing. Whenever we see e to the power x or log x, log or exponential, we'll put that only as t. That one thing should be stuck in your mind. E to the power x equal to t. We'll do this. First step is very important. First step should be this only. That all of us know. As soon as we put e to the power x as t, we know that e to the power x dx will become equal to dt. So that dx will become dt by e to the power x. Correct? Now integrate this. 1 by e to the power x minus 1 dx you are supposed to do. So this will become d to the power t, sorry, I'm sorry, what d to the power t I'm saying, dt by t. dt by e to the power x means dt by t only. So here dt will come, dx is dt by e to the power x. That means dt by t only. E to the power x itself is t. So dt by t only. So here I'll put a t. Then here I'll put t minus 1. That's it. Correct? This I know how to solve. Either I can use that format number 3 or 4, format number 2, linear by quadratic, constant by quadratic, that I can use, or I can use partial fraction over here. I'll break it into partial fraction. Directly also you can see 1 by t minus 1 minus 1 by t if you do. 1 by t minus 1 minus 1 by t if you do, what will you have? T minus t plus 1. So it will become 1 by t into t minus 1 only. Correct? So directly you can break this, you can write as integration of dt by t minus integration of, sorry, dt by t minus 1 minus integration of dt by directly you can break. So it will become ln of t minus 1 minus ln of t. This will become ln of t minus 1 minus ln of t. T is 1 by x only. So substitute it ln of e to the power x minus 1 minus ln of e to the power x. That means, sorry. If you want to solve it further, you can take ln together. Ln will become e to the power x minus 1 upon ex, e to the power x. This will become ln of e to the power x minus 1 upon e to the power x, and then you can add plus c. I won't say that remember this, but remember this approach. Don't take this as any standard integral. Don't do that. Remember the approach, so that you don't take this as any standard integral. That can be a mistake, that you try to solve it with standard integrals. No, this is not by standard integrals. This is another way. That's why this question is put here. Okay. Now comes by parts. By parts basically is a rule that just like we had division rule, product rule in differentiation, we learned chain rule or product rule. We can say chain rule is different, product rule is different. Okay. Division rule, if we have u by v, then v square uv dash minus v u dash. Correct. If we have product, then how do we proceed? If we have x into differential of second plus differential of first into second one as it is. If we have chain like function inside the function, we had different formats, different rules in differentiation. In integration, we have by parts only. We can only apply product. We can, if we have product of two different functions, then we don't have any other go other than integration by parts. See, partial fraction questions also you can solve by other formats, other algebraic formats. But by parts, where it is where you have to apply by parts, there is no other way of doing that question. Only by parts only you have to apply. Because when you have two function, f of x into g of x dx, two different functions. Although there can be some specific cases that derivative of one function is sitting there with dx. In that case, you might not have to apply by parts. But what if there is other case? In that case, you'll have to apply by parts only. F of x dx, f of x into g of x into should be separated or written like this. If you have one function and second function with dx, which one will be first and which one will be second, that I'm telling you. But this is the method. F of x as it is, then integral of g of x. First function as it is, integral of g of x dx, minus integral of entire thing. Inside the integral, you will have derivative of first function multiplied with integral of second function and integration of all of it together with respect to dx. Note this down, mug it up. Very easy. 2-3 questions if you do, you will be able to remember this without any problem. First function as it is. Now, first and second, how to choose depends on, from out of first and second, whose integral do you know? Always choose the second function as the function whose integral, because derivative you will be able to find very easily. Right? If you are thorough with derivation, then derivative you will be able to find very easily, but integrals are difficult to find. So always choose second function whose integral is, yeah, I'll explain with easy question, don't worry. Always choose the second function as the function whose integral is known to us. Direct integral is known to us. Write it down somewhere. Second function should be the one whose integral is known. Always. Remember this. Okay. Second function should be the one whose integral is known to us. First function, not a problem. First function's derivation we'll be able to do for any of the functions. But second function is important to choose. Now, just a minute. one abbreviation is followed sometimes. In some books also it is given, and most of the teachers also tell this: ILATE. Now choose your first and second function according to this. Okay, inverse is most difficult to integrate, correct? Then logarithms are also difficult to integrate. Algebraics easier, trigonometric easier, exponential even easier. E to the power x integral will be e to the power x only. So choose like this, right? Always choose the second function according to this priority. Suppose you have one algebraic and one logarithmic function. So which one is more difficult? Logarithmic is more difficult to integrate. So logarithmic function should be the first function, right? Algebraic function should be the second function. I'll repeat myself. Choose according to this. Now whichever comes first should be your first function, whichever comes second should be your second function. Suppose you have two functions. F of x is your exponential function and g of x is your algebraic function. Algebraic function is more difficult to integrate than exponential function. So choose algebraic function as first function because its differentiation you know, and second function as exponential function because its integration is going to be easier. That easy it is to understand. Okay, let's understand with basically function whose integration is easy is taken as second function. Always remember whose integration from the two functions, if you know the integration of one of the function, then always choose the function whose integration is known to you as the second function. Integrand contains only one function which cannot be integrated directly. Sometimes yes, sometimes some functions like sine inverse of x or log of x, ln of x, their integrals are not directly known. So here also we'll use by parts. Did I tell you the integral of ln of x? No. I told you the integral of 1 by x, which is ln of x. But I did not tell you the integral of ln of x. So sometimes for functions like ln of x or sine inverse x, we use integration by parts only. In this case, we'll take the second function as 1, whose integral is known to us. 1 ka integral is x. Integral of 1 dx will be x only. So second function will take the one whose integral is known to us. Here differentiation of ln x we know, differentiation of sine inverse x we know. We don't know their integrals. So if we want to find the integral of ln of x, suppose we'll take this as first function and we'll just multiply it with 1, and 1 will be our second function, and we'll apply by parts there. There might be a question related to this, don't worry. Okay, let's do some easy questions to understand and apply by parts and practice by parts. Try this one once on your own. Which function is easy to integrate? E to the power x is easy to integrate, correct? Algebraic and exponential, ILATE. Algebraic comes first, exponential comes second. So exponential should be your second function. First function should be your algebraic. Second function is easy to integrate because e to the power x integral will also be e to the power x. Although its differential is also easy, but follow ILATE. Okay, that'll give you easier. Now x square e to the power x dx. According to by parts, f of x integral of g of x. F of first function as it is, that means x square as it is. Integral of second function, integral of e to the power x dx. Okay, I'll write minus integral of differential of first function minus integral of second function. Differential of first function, what is our function? So x square dx, x square by dx, like that, right? D of x square by dx, differential of first function multiplied with integral of second function, that means integral of e to the power x dx, and this whole thing's integration with respect to dx. This is how by parts is going to be applied. Very good. Now let's apply it. X square as it is, e to the power x dx, integral will become e to the power x minus this will become 2x into integral of 2x into e to the power x dx. 2 will come outside obviously, but Here also x square e to the power x minus 2 into integral of x e to the power x dx. Do we know directly this one? No, we'll have to again apply by parts. So again we'll apply by parts. X square e to the power x minus 2 times of first function as it is, integral of second, minus differential of first function, that means 1, second function, integral e to the power x dx. And again integral of this, that means we'll have x square e to the power x minus 2x e to the power x minus e to the power x. Oh, this minus minus will become plus. Minus into minus, this will become plus. Yes, Ahan, we are starting from NCERT. Advanced questions will come along, no worry. Okay. Even I would suggest that if you are completing any chapter, covering any chapter, don't directly hop on to the difficult questions. X will be 1. Where? Kahan x will be 1? X e to the power x. 2 taken outside. So x e to the power x. Derivative of x is 1. But we didn't use the derivative of x, na? That we have taken 1 only, beta. X into integral of second minus integral of derivative of first, which is 1, into integral of second, which is e to the power x, and integration of this entire thing. Correct? Then again integration of this will be e to the power x minus 2x e to the power x plus e to the power x. I was saying that if you cover any chapter of maths, right, if you're starting from the scratch and want to cover any chapter of maths, first solve NCERT questions. There is no problem in that. Instead, it will make your concept and formulas, grasp on the formulas very tight. Okay. When will you do Wallis theorem in definite integrals? When we'll be doing definite integrals, that time. Right? It will be notified, don't worry. When we'll be doing definite integrals, after completing definite integrals, in the last part, we'll do Wallis theorem. Don't worry about it. Okay. Try this one. Apply by parts. E to the power ln x. What is e to the power ln x? X only. First, write it properly. So x sin x dx it is. Nothing but x sin x dx. Okay. Which function should be first? Eilate. Trigonometrics comes after algebraic. So this will be first. This will be second. Don't worry, Ahan. If you are waiting for Wallis theorem, definite integration, I think one lecture of 4.5 hours will be able to complete, and by the end part of definite integrals, will definitely take Wallis theorem. Okay, yes, it's an important one. For advanced, definitely it's an important one. In mains, rarely, I don't remember any question specifically for Wallis theorem, but yeah, in advanced, it will be there. And for advanced, I must tell you, we are trying to create a separate series also, where we'll discuss advanced problems, advanced concepts along with advanced problems. Although concepts are very much same only, but yeah, problems are varying. So we have to separate it, because in one lecture, we cannot do everything regarding mains and advanced. That's the limitation. Okay, so step by step. Right? X sin x dx, apply by parts. Simple. First function will be x, second function will be sin x. So first function as it is, integral of second, that means cos x minus cos x, sorry, minus cos x minus integral of differential of first function, that means 1, into integral of second function, that means this will become plus, and cos x dx. Correct? Again we'll have to integrate, so this will become minus x cos x minus, sorry, this will be sin x only, plus sin x, minus x cos x plus sin x plus c. Cos x integral is sin x integral is minus cos x. Okay. Do we have more? Ln x. Remember this. Ln x integral should be remembered. Remember the integral of ln x. Now, as I told you, how will we integrate it? It will integrate it by parts only, using by parts only. How? We'll write it like this: ln x into 1 dx. Okay, which one is easier to integrate? One is easier to integrate. So, one will be our second function. This will be our first function. This will be our second function. Okay, remember it as it is. Now apply by parts. Try applying once on your own. Ln x as it is into integral of second function, that means x. Okay, ln x into x minus integration of differential of first function, that means 1 by x, into integration of second function, that means x dx. X will get cancelled. What will have? We'll have x ln x minus 1 dx, that means x. X ln x minus x plus c. This is integral of ln of x dx. Remember this entire thing as it is. Will be used at many times, and there we cannot waste our time on deriving this, although it will take hardly 10 seconds if you are thorough with by parts, but it's better to remember because this can come at many questions. Okay, remember this. C cube x, sec square x we know. C cube x, do we know? Is there any direct thing for that? No. So what we'll do, we'll apply by parts. I'm just showing you the scenarios where you might need to apply by parts, right? So that you become comfortable with it. Sometimes, very simple problem will come, but because we are not able to think of by parts, that's why we'll not proceed with it, or we'll make a mistake there. Okay, sec cube x. So can be written as sec square x into sec x. We know the integral of sec square x. We don't know the integral of sec x. So this will be first. This will become second. We know the integration of sec square x. Okay, that's why second is sec square x. We'll write it like this. Now, what will your integral become? Sec x as it is. Sec square x integral will become tan x minus integration of differential of first. Sec x differential will become sec x tan x. Sec x differential will become sec x tan x, and sec square x, or just simply do differential of this, so it will become sec square x into tan x. Sorry, ulta I have written sec x into tan square x. Sec x into tan square x dx. Now what to do? Can we proceed ahead? Tan square x, do we know? No standard integral. This we'll have to write in terms of x again. That will be sec square x minus 1. Now here one important thing will come that you might have used, but yeah, revise that once again. There, see, sec square x minus 1 is coming. Okay, I, let's say, is equal to sec x tan x minus integral of sec x into sec square x minus 1 dx. This thing is coming, correct? So this can be written as sec x tan x minus integral of sec cube x minus integral of sec x, right? So minus integral of sec cube x, that means my original I, what was my I? I was this only. I've taken this only as I. Correct? What was my I? I was this only. Sec cube x dx. Right? So here what will be created? Sec cube x minus sec x. Sec cube x, integral of sec cube x minus integral of sec x. Integral of sec cube x is nothing but I only. Minus plus this minus and minus sec x. So plus integral of sec x. Correct? Integral of sec x I know. Okay. Now what will happen? This I will come on this side. So we'll have 2I equal to sec x tan x plus integral of sec x. Ln of sec x plus tan x. Right? Ln of sec x plus tan x. Sir, why did we use it over here if we knew the integral? Integral of sec square x was much easier than sec x. Correct? Much easier to write and manipulate. That's why. That is also one reason. So now what are we going to have? We'll have integral equal to 1 by 2 sec x tan x 1 by cos x. Acha, theek hai. Sec x tan x, let it remain like this, plus 1 by 2 into ln of sec x plus tan x plus c. That way we can write and leave it. Okay. 1 by 2 they have taken common. All right. In this type of questions also, by parts will help you. When you see such kind of power, this is repeated. I think this was there in 19 or I think 20. Not same question, but similar type. Okay. Here also, by parts will help you. The only thing is that you should be able to see that by part is applicable here. How will we see? Just see. Just try to think that how will we see that by parts is applicable over here. See, this thing is what? Sec square x by sine to the power 2022. Correct? X. Correct? Minus 2022 by sine to the power of 2022 x. This thing only is written, no? This entire thing dx. Check once. This we can write, this part we can write as sec square x into sine to the power of minus 2022. Correct? Now you can see by parts is actually applicable here. Yeah, minus this, so minus 2022 will come outside, minus integral of, okay, let's write here only 2022 sine of minus 2022. Correct? What we learned just now in the last one, I'm not writing dx because of lack of space, but you can understand. What we learned just now in the last question, sec cube x, will be applicable here also. Just see how. Here we can apply by parts. We know that integral of this is known, integral and differential of this will be easy. Differential though we can do, derivative we can do with anything, right? We are that thorough. Correct? Here there is a problem, but that problem will be resolved as soon as you apply by part. First function as it is, that means sine to the power minus 2022 as it is. Integral of second, integral of sec square, that means tan x. So into tan x minus integral of differential of first. Differential of first will be sine to the power minus 2023. Minus 2022 will be applied. Minus 2022 will be multiplied. So plus will come here. Minus we can take out differentiation of sine of minus 2022. Minus 2022 into sine of minus 2022 plus 1. Minus 1, sorry. So minus 2023. Correct? So this will become sine of minus 2023 x. Differentiation of first into integral of second. So cos x tan x into integral of second, that means cos x tan x. Check it out. Wait, are we doing something wrong? Yes, we are doing something wrong. Wait. This will become minus 2022 will come outside. Right. Minus 2022. Hey, we are doing this only. I was paying attention at this. We are doing this only. First into integral of second minus integration of first derivative, that means minus 2022 sine of minus 2022 okay, this is okay. Then integration of second, that means cos x tan x. Yes, this is also okay. So this will become sin x by cos x. Cos x will get cancelled. Sin x will get multiplied over here and it will become minus 2023. Correct? This will become minus 20. No, sorry. This was minus 2023 already. N minus 1. Na? So minus 2022 minus 1 minus 2023. Now cos x by cos x, sin x will remain here. This will become, this thing will become your sin x only. Cos x into tan x, sin x only. And this sin x multiplied with this again will make it minus 2023 plus 1, that means minus 2022 again. So this will become sine of minus 2022, I'm writing again, dot tan x minus plus, it will become minus minus plus, so 2022 integral of sine of 2022 again will come, because sin x into sine of minus 2023, so sine of minus 2022 again only will come. Okay, minus this thing is there, minus this thing, that means minus of 2022 integral of sine of minus 2022. Now you see, this and this are getting cancelled. So final integral that we have is sine of minus 2022 tan x tan x. Okay. This is your final integral. So this will become 1 by sine of 2022 sin x by cos x was happening, right? So 2021, let's do it. 2021 tan x I'm breaking as sin x by cos x. So this will become 1 by sine of 2021 x cos x plus c. Okay. Now what have they asked? I of, this is I of pi by 4. So that you'll have to calculate. I of pi by 4 is equal to 2 to the power of 1011. So x, when you'll put x as pi by 4, what will create? 1 by root 2 to the power of pi by 4, that means 1 by root 2, 1 by root 2 to the power of minus 2022. Okay. Plus c minus 2 to the power of 1011 equal to first we'll have to calculate c. So I of 0 we can put, no, I of pi by 4 is given to us. So I of pi by 4, let me calculate. I of pi by 4, that means here you'll have to put pi by 4. So that is equal to 2 to the power of 1011. 1011, that means 1 by root 2 to the power of pi by 4, 1 by root 2, 1 by root 2. This is also 1 by root 2. This is also 1 by root 2. So it will create minus 2022. Correct? Check once. Minus 2022 only. 1 by root 2 to the power. Both are 1 by root 2 at pi by 4. Plus c. Plus c. 1 by root 2 to the power this. That means 2 to the power minus 1 by 2 into 2022. That means 1011 only. Right? This will be 2 to the power minus 1 by 2 minus 1 by 2 into minus 2022. So 2 to the power 1011 only. That means from here what we are getting, c equal to 0. That's what we are getting. Right? C is coming out to be 0. Now what are they asking? I of pi by 3 and I of pi by 6. Okay, let's check. C will come out to be 0. I of pi by 6 will come out to be this 1 by root 3 into 1 by 2 to the power 2022, and I of pi by 3 at pi by 3 it will become root 3 by 2 to the power of 2022. Subtraction of these, what have they asked? They have asked a relation between these two. Okay, so yes, this relation will be pure 2 to the power 2022 upon root 3, and here 1 by 3 to the power 1010 at I equal to pi by 6, at x equal to pi by 6. So this relation is sustaining. That you can once check on your own. Okay, in this case, now here actually some specific formats I'd like to remind you once again of when we did these type of formats. Integration of if f dash is sitting in the numerator and f square is sitting in the denominator dx. What was this? This was minus 1 by f plus c. Remember here, I think that will be used. First, let me write these for your help. F dash upon f square, if it is there, and okay, and f dash upon f also you must know, right? F dash upon f, you know, f you'll put as t and then you'll proceed. So ln of f, that's it, ln of f, that you know. This one I'd like to remind you, rest you know. Now see, look at the question. Now problem is that we are not able to think of, we know that products are coming, two different functions are there, x square is there and then trigonometric functions are there. We know that by part only can solve this problem, but we are not able to apply by parts that easily. Correct? Why? Because we don't know, x square is not sitting, x square is mixed up with, both the function are mixed up. X square is not separate, only x square is not separate. There is x here also, x here also. That's why we are not able to apply by parts directly. Give it a try for a minute. I'll just drink some water. Give it a try to think how will you be able to solve it. See, if you pay attention, which integral do we know? Which integral will be easier? Which integral will be easier? Sir, if we, obviously sir, x square integral will be easier. Huh? So here the thing is, here the main problem is that which function should we choose as first and which function should we choose as second. Although we know that integral of x square is easier, but differential of first one will complicate our problem. Correct? Derivative of first one will complicate our problem. Correct? And most importantly, it's not x square and different trigonometric function without x square. In trigonometric function also there is x. So it's not that x square we'll be taking as the second function. No. Because x, if it was x square was completely separate and we only had sec x, tan x plus 1. X was not multiplied here. Then we could do that x square we can take as second function because integral is easy there. Correct? Correct. Trigonometric functions integrations are actually easier than algebraic. According to ILATE also, if we follow ILATE, that abbreviation, that also says that Baba, take trigonometric as second, algebraic as first. Okay, but here they are mixed up, first of all. Now, why did I remind you this? F dash by f square. F dash by f square. What is the differential of x tan x plus 1? X tan x plus 1. Is it written in the numerator? Yes. Differential of x tan x plus 1 is x sec square x plus tan x. Right? Apply product rule na. X sec square x plus x into differential of tan x, that is sec square x, plus tan x into differential of x, that is tan x only. So differential of denominator is there in the numerator. Definitely finding the integral here will be easier because of this method. Whenever we have f dash upon f square and we have to integrate that function square and its derivative is sitting in the numerator with dx, then its direct result will be 1 minus 1 by f plus c. If we remember this problem is not going to bother us at all. Now we don't have to do anything, we'll just write this as x square. So I of x will be equal to x square into this thing, x square into x sec square x plus tan x divided by x tan x plus 1 whole square, right? This thing dx. Okay, now this you choose as first, this you choose as second, because you know now you are able to write its differential. It's a trigonometric function and its integral you are able to write because of that particular formula that we learned. Remember every formula, every format, then only we can proceed strongly in differentiation. So now x square as it is, integral of this, what will it become? Minus 1 by f, that means minus 1 by x tan x plus 1, correct? So minus 1 by x tan x plus 1. All right. Then minus integral of differential of first, that means 2x, without any problem, right? So 2 will take outside, 2x, x will take inside. Integral of second, again this will be minus 1, so minus and minus, this will become plus, right? Minus 1 directly 1 by this thing only, x tan x plus 1, x tan x plus 1, x into x tan x plus 1. So let me write this more neatly, x by x tan x plus 1. But integral here we'll have to find out. This still has to be integrated. Differential of first into integration of second and integration of the entire thing with respect to dx. How will we integrate this? Put tan x, this tan x, right? This tan x, if we take as sin x by cos x, what will this become? X sin x plus cos x, and cos x will go up there. So this is x cos x upon x sin x plus cos x, correct? Which form is this? This is f dash by f, that we know very easily. F dash by x, we'll put this as t and its derivative is sitting there. If we put this as t, its derivative is sitting there. What will be the derivative over here? X into cos x minus, plus sin x into 1. X cos x plus sin x minus cos x will happen. So cos x will sin x will get cancelled, and we'll have cos x only. X cos x only will be remained. Correct? What will this become? The derivate the denominator. What is f dash? If this is f, what will be f dash? F dash will be x cos x plus sin x minus sin x. X cos x plus sin x minus sin x. So sin x got cancelled, only x cos x will remain. So which form is this? F dash by f. F dash by f, we'll put this as t. This will become dt by t, ln t, ln of x cos x sin x plus cos x. That is it. So this is nothing, x square minus of x square. Acha, x got cancelled here also. No, nothing is getting cancelled. X, wait, let me change the color. Minus of x square by x tan x plus 1. This part plus 2 ln of t, 2 into ln of x sin x plus cos x plus c. Achha, these are options. A, B, C, D are not written. Sorry, don't confuse with this thing. Okay, this will be your final integral. Correct? Now solve this. I of pi by 4, put x as pi by 4 over here. Pi by 4 into 1 by root 2. So this will become, wait. C will come out to be 0, right? As soon as you put I of 0, when you will put, this will become 0, this will become 0. So C will come out to be 0, correct? As soon as you have C as 0, I pi by 4 you will be able to find. I pi by 4 will become ln of pi plus 4, ln of pi plus 4 over here, pi by 4 into 1 by root 2 plus 1 by root 2, 2 by root 2 pi by 4. So 1 by 2 root 2, pi by 2 root 2, that means pi plus 4 whole square by 32. This thing will become pi plus 4 whole square by 32, ln, definitely. Okay, ln. And this side we will have minus pi square by 4, pi square by 4 square plus pi by 4 plus 1. So 1 plus 1, 2, and that will cancel this 2. So pi square by 4 into pi plus 4. This will become pi square by 4 into pi plus 4. Okay. This 2 sent above. So 2 to the power 5. That means 32 here. That's why 32. Okay. We have sent this 2 above. Now also we don't have, yeah, we have this. So which option is correct? This option is correct. Plus we have plus here, 4 into pi by 4. Achha, this is minus. Sorry, wait. This is minus. No, here we have a minus, right? So second option will be correct. Here we have a minus. We forgot this minus. It's not minus x whole square, it is minus x square. Okay. Now, some important results where we can apply by parts, but it's better that we remember these results. E to the power ax cos bx dx will be e to the power ax upon a square plus b square. A cos bx plus b sin bx. If you apply by parts, you'll get the answer very easily. But it will take 1 minute of yours, 1.5 minutes also it can take if you apply by parts in this case, right? When powers are actually there, a and b have value. If both are 1, then by parts will be easier. But if they have some other value than 1, then it will be difficult. So it's better, it's recommended that you remember these results also. These formulas, not results, as formulas you remember them. E to the power ax cos bx integral will be e to the power ax upon a square plus b square multiplied with a cos bx plus b sin bx. Cos and sin both have bx only because here cos bx. Okay, same thing for sin, nothing changes except minus over here, and a sin bx minus b cos bx. A sin bx minus b cos bx. Minus will be with cos only. Minus will be with cos only. That way you can remember this. For example, it can help you in a question like this, right? For example, e to the power, what is a? A and b both are 1 over here, right? A and b both are 1 over here. So according to the formula, e to the power ax, that means e to the power x, divided by 1 square plus 1 square, that means 2. Correct? Multiplied with sin ax plus cos bx. Sin ax, that means sin a is 1 only, so sin x plus cos bx. B is also 1, so cos x. Directly you will be able to write plus c. Right? Applying by parts is not a problem over here, but if you remember, it will save a lot of your time. Sometimes in problems this will be there in between. Okay, see, by parts also you are able to apply first into integral of second minus integral of differential of first into integral of second. That way also, but here by parts you'll have to apply at multiple steps because e to the power x is sitting there. Okay, at multiple steps you'll have to apply by parts. So that's one reason that just a minute please. Just a minute, hold on. I'll move on to the next problem. Just a minute. Okay. One more problem. Function inside function. Have we learned this chain rule? Is there any chain rule in integration? No, there is no chain rule in integration. But one thing we know, whenever we see log, we put that as t. We substitute that as t. So make this habit. As this is ln of x as t. Just put off your ln of x equal to t. Substitution is static everywhere. So here x will become e to the power t. Correct? X will become e to the power t. What will be the integration? If you differentiate both the sides, this side will have 1 by x and this side will have dt. 1 by x dx. So dx by x. That's it. Okay. Now you can proceed with this. Now your problem becomes cos of t dt. Cos of t dt. But t is what? Sorry, cos of log of x by e we have taken as t. So cos of t dt. But what is dt here? Dt itself is dx. Cos of t dx. Here dx will come. Cos of t dx will come, but dx is dt into x, where x is e to the power t only. So here what you will have, e to the power t cos of t into the e to the power t dt. That way we can write. Dx will become dt into x. X itself is e to the power t. So this will be your problem. Now you can apply by parts, either by parts or direct result also you remember. So this will become e to the power t by 2. A and b both are 2. Cos t plus sin t. Cos t plus sin t. So I'm not just saying simply the importance of remembering the results over here. So you can see it's a PYQ, and if you remember the result, this question can be done in less than a minute if you apply correctly. Okay, t's value you can put. T's value you can put again. T is ln of x, so e to the power t will become again x. So x by 2 into sine of log x. Here x by 2 into cos of log x by e plus sine of log x by e plus c. Simple answer. You will have option C. Directly you will be able to mark in this particular case. Now see, sometimes what will happen, this question is there to tell you that sometimes you'll have to forcefully put by parts. Direct by parts won't be applicable, but forcefully, if you're not able to think of something else, this type of function we have not seen in integration. There is no standard, there is no format base. We have not done trigonometric formats also yet. So this type of format is new to us. Sometimes we'll have to create by parts. That is also possible. We can create by parts somehow. For example, over here only, if you see what is the derivative of x sin x plus cos x. Derivative of x sin x plus cos x will be x cos x. Correct? Derivative of x sin x plus cos x will be x cos x only. Correct? Directly you can see. Derivative of x sin x plus cos x will be x cos x. Only just now we saw this in a problem right before this question or a couple of questions. Correct? So in this case, what we can do, we can create the derivative in the numerator. Correct? We can create the derivative in the numerator, yes or no? What will this be? This will be x square by x sin x plus cos x whole square. Correct? Dx. And we know that derivative of x sin x plus cos x is equal to x cos x. This also we know. Correct? What can we do? Can we create x cos x over here? If we are creating here, then here also we'll have to create cos x. We'll have to create means multiplied and divide with cos x, so that we can create x cos x in both the signs. Okay. Now break this. Right? One x cos x separately, another x cos x separately. So x by cos x I'm writing. This will be written as x by cos x. One x by cos x I'm taking over here, multiplying it with x cos x by x sin x plus cos x. And obviously the whole square. Now why did I do this? Because now I can integrate this f by f dash form, f by f dash square form, which is minus 1 by f plus c. Correct? F by f dash square form. So this one I'll take as 1, this one I'll take as 2, and I can proceed. So it will become x by cos x into f by f dash, that means minus 1 by f, that means minus 1 by x sin x plus cos x. So minus 1 by x sin x plus cos x. Okay, plus integral of differential of first into second. Integral of differential of first. So here, you know, dividend rule you'll have to apply. When will areas class start? Areas after definite integrals. Then only we can do area under the curve. Or meanwhile, if I'm able to take 2 lectures of definite integrals, then I'll take area under the curve there only. Okay. Suman says ek hi hai. Ha, correct. Ek hi hai. Now here, so derivative of x by cos x, dividend rule, cos square x will come in the denominator, x into minus sin x minus cos x. So here I'll have x into minus sin x minus cos x divided by cos square x. Derivative of this, integral of derivative of first into integral of second, which is again minus 1 by, this will become minus 1 by same thing, x sin x plus cos x. X sin x plus cos x. If I take minus common from here, this minus and this, these minus will get cancelled. This will cancel by this. 1 by cos square x, that means sec square x. Integral I'll have, nothing else. So this thing, this entire thing is going to become, this entire thing will become integral of sec square x dx. Correct only, right? 1 by cos square. So this will become tan x simply. This will become tan x. So that means tan x is there in the option first one. And this will become minus x sec x divided by x sin x plus cos x. First option. Somebody gave the answer by parts. By parts. But applying by parts was not, go away. We could not, was not, the first thing which would come in our mind. Because we have to create by parts over here. How will we? Standard function is not there. Standard format is not there. So we had to create by parts. Sometimes, not sometimes, every time. Looking at the numerator with respect to the denominator is very, very important. Very important. If you are able to see the derivative in, in numerator and denominator, some relation with the derivative, try to create the derivative above and, something will come along. Something will come along. Integration is never possible without being mastery in differentiation. Okay, remember that. That's the first requirement. Now, trigonometric formats is one thing which we need to do. Trigonometric formats, see, are very easy, but were very important. Very easy to apply, but important. In questions of mains specifically, I would say, not even in mains, in advance. If a complicated question is to be made, they'll definitely use trigonometric formats. And without knowing the standard approach for trigonometric formats, we'll get stuck in the problem. Even after knowing the entire chapter before this, by parts, partial fraction, the formats, algebraic formats, normal methods, everything, reduction formula, very good NIT. So, without reduction formats only, I'm not giving any separate reduction formula here. Format itself is going to be used. So whenever you see something like this, sine to the power something and cos to the power something, sin x, cos x, and both sine and cos have some powers over there and we have to integrate them. Or tan and sec are together with dx and we have to integrate this. In this case, pay attention at the power. So suppose, for example, suppose we have something like this, sine to the power of 4x, cos to the power of 5x, something like this, dx. So main approach, I'll tell you, take sine to the power mx as t or cos to the power nx as t. We have to do this substitution. Obviously, we either take sine as t or cos as t. That can be the working strategy over here. Either, not to the power m, actually sin x either will take as t or cos x will take as t. Anyone. But which one will be more suitable? We can go ahead with any substitution. Take either sin x as t or take either cos x as t. Okay. Yes, Nati Warangal, we are trying to do that, and we'll also try to launch a crash course if possible. Okay. Either sin x will be taken as t or cos x will be taken as t. Okay, ji. Now, which one to take? That's very important in this case. In tan and sec also, that is only very important in this case. So, if whichever has even power, take that as t. If sine has even power, if sine has even power, then take that as t. For example, this problem, sine 4x cos 5x, this only I have written, sine 4x cos 5x. If sine has even power, take sine as t. Okay, so that its differential will help you. For example, over here, let's look at this problem only, part A. Take sine to the power 4x, we have cos to the power 5x, we have dx. Okay. Whichever has even power, take that as t. Power even can be 0 also. Suppose cos is not there only, right? Or cos to the power, we have sine to the power 5x. Suppose we have sine to the power 5x. So we'll take cos x as t because cos is there but with power 0. Remember this approach. Whichever has even power, take that as t. Okay. Suppose sine to the power 4x, cos to the power 4x we have. Okay, sine, now here what we'll do, sine x you take equal to t. Differentiate, so you'll have cos x dx equal to dt. As soon as you do this, you'll have sine to the power 4x, that means t to the power 4 multiplied with cos x. Now write in terms of sine. Now see, why did I say sine only should be taken as t? Because see, when you'll do sine, when you'll convert in terms of cos, when you'll convert in terms of sine, what will you do? How will you do it? Dx, what is dx? Dx is dt by cos. Correct? Dx is dt by cos. So here dt by cos x will come. Cos x will cancel one of the power. Odd power will be a problem. Even powers will be able to manipulate. So that is why we are putting sin x as t. So when we put sin x as t, cos x dx become dt and dx becomes dt by cos x. This by cos x will cancel one of the cos. So now we'll have cos, I'll write one step. Cos to the power 5x into dx. What is dt? Sorry, what is dx? dt by cos to the power 5. Cos to the power, sorry, cos x. dt by cos x. So this will cancel one of the power and it will be power 4. Correct? So that is the reason. So this will become cos to the power 4x. Cos to the power 4x means 1 minus sine square x to whole square. So 1 minus t square to whole square into obviously dt. Correct? And now we can proceed very easily. This will become integral of t to the power 4 plus integral of t to the power 8 minus integral of 2 into t to the power 4 into 2. So 2 into t to the power 6 plus c. This is why. Now suppose if we had sine to the second case. In second case, look, in B part, we have sine to the power 5x. Right? Let's take more space. We have sine to the power 5x. We don't have now sine to the power 5x. Sin x if we take as t, suppose. Cos x dx will become dt. But dx will be dt by cos x. Where will we adjust that cos x? We are already struggling and we'll complicate it again. So if sine's power is even, then we'll take sine as t. Here sine power is odd. Cos power is even, we'll take cos as t. Here cos power is 0. There is no cos, so cos power is 0. So in second case, we'll take cos x as t. Why? Because this will become minus sin x dx equal to dt, which will cancel one of the cos. Correct? This will become minus sin x dx equal to dt. And your dx will come out to be dt by sin x negative. Now when we'll adjust it there, right, my dx became minus dt by sin x. And what did my sine become? Sine to the power 4. Now this thing, what will this thing become? This thing will become sine to the power 5 x into dx is dt by sin x. Correct? Dt by sin x, this will cancel one of the power. I'll have sine to the power 4x. What is sine to the power 4x now? In terms of cos x, 1 minus cos square x whole square. Sine to the power 4x can be written as 1 minus cos square x whole square into dt. And cos I've taken as t, so instead of this I'll just write 1 minus t square whole square dt. Now I can proceed. Correct? So remember, if whichever power is even, that you should take as t. C wala question sin to the power 5 by 5. C wala question sin to the power 5 by 5. Hanji. Correct. Sin to the power 5 by 5, are you sure? C, not C. I thought you're telling B. Sin to the power 5 by 5. No. Sir, if both are even here, Sine is also even, cos is also even. Cos is not there, so 0. That is also even. Correct? Both are even. I did not tell the case in that. Now what will you put? If you take sin x as t, cos x dx will become dt. Dx will be dt by cos x. Where will you adjust that? If you take cos x as t minus sin x, dx will become dt. Sine cube will be created. Sine cube in terms of cos. 4 cos x, 3 sin cube, 3 cos cube x. Very difficult. It will complicate a lot. So in case 3, if both powers are even, you don't use t here. You use half angle formula. Oh, sorry, multiple angle formulas. You take this into multiple angle. You take sine to the power 4x dx. Sine to the power 4, try to write it in form of multiple angle. Sine square x is 1 minus cos 2x by 2. So this will become 1 minus cos 2x by 2 whole square dx. Correct? 1 by 2 whole square will come out. So 1 by 4 will come out. And you'll have 1 minus cos 2x whole square dx. This you can still solve. So this will become 1 plus cos square 2x minus 2 cos 2x. This will become 1 by 4 into 1 plus cos square 2x minus 2 cos 2x. Now you can solve this. Correct? Cos square 2x again you can write as, again take it into multiple angle. So it will become 1 by 4 integral of 1 plus 1 plus cos 4x. Cos 2x we wrote, no, sin x, 1 plus cos 2x by 2. So 1 plus cos 4x by 2. 1 plus cos 4x by 2 you can write. 1 plus cos 4x by 2. Cos square you don't know. Cos 4x you can write. Please do PYQ section. Yeah, I'll proceed with that series. Don't worry. 1 plus cos 4x by 2 minus cos 2x though you can find, right? 1 by 2. So let it be like this. 2 cos 2x. From here, now you can write the differential without any problem. 1 by 4 will become 1 by 4x. You can write the integral. Did I say differential? Sorry. 1 by 4x. Here what we'll have? 2 plus cos 4x by 2. So 2 plus cos 4x by 2, 4 into 2, 8. Okay, let's write it like this. 1 by 4x plus 1 by 4x only, no? 1 by 4x plus 1 by 4x. 1 by 4x plus 1 by, 1 by 8. 1 by 4x plus 1 by 8x. What am I doing? 1 by 4x, it will be there. 1 by 8 will be created here. 8 plus 1 plus cos 4. No, wait. Directly we can write 1 by 8 into integral of this sine 4x by 4, na? So into sine 4x by 4 minus 2 cos 2x by 2. So cos 2x only. Correct? Have I done it correct? Check once. Arey cos 2x directly by sin 2x. 1 by 2, 1 by 2. 1 by 4 I did not multiply, so 1 by 4 will be there. Now I think correct. 1 by 8 into sine 4x by 4 is correct. Minus sine 2x by 4 is also correct. And 1 by 4x is also correct. This will be the final integral. This is how you'll have to solve. If both powers are even, take them into multiple angles because substitution will not help in that case. Now, this part. Here the sum of powers is helpful. Sum of powers is beautiful over here. Correct? Sum of powers is going to help us. What is the sum of powers? 14 by 9 plus 4 by 9. So 2 square. Sum is square. Whenever sum of the powers of sine and cos are giving you a suitable result, simply do one thing. Divide by same power of cos. Right? Divide by the power which is giving you the sum. How should I say this in... for example, over here, what is the sum of the powers? Square. sum of the powers is square, divide the square of cos, 1 by square of cos in both numerator and denominator. Multiply 1 by cos in both numerator and denominator, or I shall say divide the denominator by 1 by cos square. So in numerator also you'll have to do the same thing. So what do you do in D? What do you do? 1 by cos square x in the numerator, and in the denominator also 1 by cos square x you will multiply. So it will become sine 14 by 9 x cos 4 by 9 x, right, by cos square x dx. You know what did the numerator become? Numerator become sec square x. Numerator became, now you can see it helped, right? So whenever sum is giving you a suitable result, divide by the sum of, like divide by the cos to the power sum of the powers of these two. Suppose the sum was 3, so we'll divide by cos cube. If the sum of powers were 4, we'll divide by cos to the power 4. That's how. So this will become sec square x in the numerator. Denominator you can see 4 by 9 minus 2 by 9. 4 by 9 minus 2. And sine. So here what will become? Tan to the power of 14 by 9 will be created. Right? Tan to the power of 14 by 9 will be created. Sine to the power 14 by 9 divided by cos to the power 14 by 9 will be created. Correct? This will become cos to the power of minus 14 by 9. Sorry, here cos to the power of minus 14 by 9. So sine to the power 14 by 9 divided by tan to the power 14 by 9. This will be created. This we can easily solve. Just put tan x equal to t and you'll be able to solve it without any problem. Put tan x equal to t and you'll be easily able to solve it. So your sec square dx will become dt. Correct? So it will become dt by t to the power 14 by 9. Simple integral. Okay. And put back the value of t again. Now part E. In this case also tan x, whichever has, in this case whichever has odd power, when tan x and sec x are multiplied, whichever has odd power, just put that as t. For example, over here tan x has odd power, so put tan x is equal to t. As simple as that. So sec square x dx will become your dt. So problem will be t cube dt. That's it. Tan x sec square dx will become dt directly. Tan cube x, that means t cube dt. And then you can substitute back your tan. In this case, both of them have odd powers. So anyone, right? Here what will help us? If we put sec x as t, here sec x as t will help us. So that sec x tan x, so that sec x tan x can become dt. So simple substitution only. Okay. Anyone you put in these cases will help, but you have to smartly think which is helping me more. For example, here sec square x was sitting, so tan x as t, sec square dx, sec square x dx became dt. As simple as that. Here tan cube x is sitting there. So if we take tan x as t, sec square x will come, which we don't have. Correct? So it's better that we put sec x as t. Sec x as t gave us sec x tan x as dt, and we can simply sec x tan x as dt. So this will become t square dt. That's it. And the problem is solved. Tan square x dt. So t cube by 3 minus t, tan cube x by 3 minus 3, minus tan cube, minus tan x. Sorry, t we took as sec x, so sec cube x by 3 minus sec x. Okay, so this is format number 1. Now you can see all these. Format number 2. Whenever we have linear in sine and cos. Whenever we have linear in denominator, if we have a linear format in sine and cos, right? Whenever we have a linear format in sine and cos, for example, over here we have linear. This is linear, this is linear, this is linear. Always take sin x and tan x, sin x and cos x in terms of tan. Two things are mandatory for this format. First, numerator should have a function of tan. Denominator should be in a linear in terms of sin and cos. Whenever this is the case, always take your sin x and cos x in terms of tan. And for them, you'll need these two formulas. You know, sin 2x is 2 tan x divided by 1 plus tan x, tan square x, and cos 2x is 1 minus tan x divided by 1 plus tan x. So sin x will become 2 tan x by 2 divided by 1 plus tan square x by 2, and cos x will become 1 minus tan square x divided by 1 plus tan square x by 2. 1 minus tan square x by 2 and divided by 1 plus tan square x by 2. So you can see this is definitely going to help you. Let's see this problem. Numerator there is nothing, but denominator there is a linear in. Why should sec x not? Sir, mixed question are coming. Jay, please discuss the questions, please. Mixed question of matrix and integration. Correct. Okay. Thank you, NIT Warangal. I'll take that. I'll bring some questions like that in PYQ series. Okay. Yes, some questions like that are coming. Mixed questions have always come, but nowadays they've started mixing up too much. Earlier, this used to happen in advanced, but because of the competition, JEE Mains is becoming advanced now. Why should sec x not? Okay. I hope you understood, right? So here we have in denominator, here we have tan function in the numerator. Here we don't have a tan function in the numerator, but denominator we have a linear in sine and cos. So same working strategy will be same. We'll take sine and cos in terms of tan. So this will become dx divided by 1 plus 2 cos x. That means 2 into 1 plus tan square x by 2. Oh, sorry, 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Okay. How will this help us? Numerator, what will numerator become now? Denominator will be 3 minus tan square x by 2. What will be your denominator? Denominator will be 3. Wait, let me write only the denominator first. Denominator will be 3 minus tan square x by 2, and this 1 plus tan square x by 2 minus 2 into 1 plus tan square x by 2 will make it sec square x by 2. Tan square x by 2 minus 1 will come, so sec square x by 2 will be created in the numerator. Now this format, you know. In this format, just simply put tan of x by 2 as t, because its derivative is sitting in the numerator. As soon as you put tan of x by 2 as t, this will become 3 minus t square, and sec square x by 2 dx will become dt. Okay, dt upon root 3 upon t square. Root 3 minus t square. Root 3 square minus t square. Standard format. Right? Here again same thing. In B also do the same thing. Write cos and sine in terms of tan. Here also write cos and sine in terms of tan. I hope, yeah. This question only, right? Cos and sine in terms of tan. Cos in terms of tan, sine in terms of tan. Numerator will become 5 tan x by 2 plus 3 into sec square x by 2 dx. Again you will put tan x by 2 as t, and your numerator will become this. Numerator you have already this, right? Tan of x by 2 you have taken as t. So 5 of t, 5 times t plus 3 into 2 dt divided by 2 into 5t square plus 4t plus 8. And this format, you know, linear by quadratic. Just write the linear with lambda into derivative of quadratic plus mu. Method of integration. Very good. Simple method of integration. Third format, when you have linear by linear in terms of cos and sine. Whenever you have linear by linear in terms of cos and sine, either you can have p cos x plus q sin x upon a cos x plus b sin x, or you can have p cos x plus q sin x plus r. This is simple linear, no constant. Here constant is also there, right? So in both the cases, simple thing, numerator, just like we do our method of differentiation or in format number 3 of algebraic, write this numerator, just write your numerator as lambda into derivative of your denominator, okay, plus mu into, lambda into denominator to the power r, denominator to the power something, plus mu into derivative of your denominator. For example, let's see a question over here. Wait, we don't have here. I forgot to keep any question for this format. Let me look for some question. Integral of 2 sin x plus cos x divided by, let's take 7 sin x minus 5 cos x. Okay, both linear, different different coefficients, but both linear. Partial fraction y. Here, how will you apply partial fraction? Trigonometric formats are there, no? Correct? So what are you supposed to do? You'll write your numerator 2 sin x plus cos x. This is your numerator. This you have to write in terms of denominator. How? In terms of denominator? Lambda, same thing as lambda into denominator. That means minus 5 cos x. If it had some power, then you'll use that power also, right? Plus mu times the differential of your denominator, plus mu times the differential of your denominator. That will become 7 cos x plus 5 sin x. Become 5 sin x. Just do this much. If both are linear by linear in trigonometric formats, then write your numerator like this, lambda into denominator. If denominator has some power, then put that power also. If there's square there, then put square there. Put square here also. Plus mu into this. Mu into derivative of denominator. This is the derivative of denominator. And now find lambda and mu. So what will our 2 be equal to? 2 will be equal to 7 lambda plus 5 mu. 7 lambda plus 5 mu and cos x coefficient. So 1 will be equal to minus 5 lambda. 1 will be equal to minus 5 lambda plus 5 mu. Cos x ka na? Plus 7 mu, sorry. Plus 7 mu. Plus 7 mu. Find lambda and mu. Lambda will come out to be, just simply add. No, we cannot add. Oh God. Lambda will come out to be let me calculate, just a minute. 9 by 14 2 4 9 by 74 and 17 by 74. 9 by 74 and mu is coming out to be 17 by 74. Just check once if possible. Now you'll write everything in terms of this. So your integral, this thing, this entire thing, you'll write in those terms. So it will become integral of lambda into this. That means 9 by 74 into 7 sin x minus 5 cos x into 7 sin x minus 5 cos x plus mu is 17 by 74. So 17 by 74 हो 17 by 74 into 7 cos x plus 5 sin x. Divided by this, of course. Divided by 7 sin x minus 5 cos x. How did this help? Now you can write both of them, no? 9, so 7 sin x minus 5 cos x divided by 7 sin x minus 5 cos x, not a problem at all, will get cancelled. Plus 17 by 74 into 7 cos x plus 5 sin x divided by 7 sin x minus 5 cos x. This as t, this will become dt. This you'll take as t, this will become dt. Okay, this you'll take, no NIT Warangal, I just put both the equations in the math app, right? I have an app, Photomath, where you can write the equation and quickly you'll get the solutions. So that's how. Just check once, sometimes it gets, Photomath you guys know, right? Yeah, sometimes Photomath helps a lot in quick solution of equations. Alright, now you know this by this gets cancelled, so 9 by 74 x plus 17 by 74 ln of this, because f by f dash format is there, correct? So final answer will become 9 by 74 x plus 17 by 74 into ln of this 7 sin x minus 5 cos x, as it is, plus c, obviously. Correct, right? I hope everybody understood. This is the derivative of this 7 sin x minus 5 cos x, derivative is this. So this you'll take as t. Here you'll have dt, dt by t format will be created, which is ln of t. That's why directly I'm writing. Okay. Format number 4, quadratic in denominator. Quadratic, if you see in trigonometric formats, in sine cos especially, if you see a quadratic in denominator, simple thing, divide your numerator and denominator by cos square x. Always it will work. And then put tan x equal to t. Divide your numerator and denominator by cos square x, and in the end put tan x equal to t. When to do this? Whenever you have a quadratic of sine and cos in your denominator. Numerator can be something else also. Let's see some questions. Numerator will be constant only in these cases. If you have a quadratic in sine cos in the denominator, numerator will be constant only. Dx by 1 minus cos 4x, try solving it. Divide by cos square x, numerator denominator. What will numerator become? Numerator will become sec square x. Very good thing. You like it already. So many times it has been used. 1 minus cos square x divided by cos square x. So it will become sec square x minus 4. This divided by cos square x. This will become sec square x minus 4. Correct. Now put tan x equal to t. Okay, wait. Sec square x minus 4 nahi. This will become sec square x minus 4 only. But here, how will we now? The next step was tan x equal to t. But how to create tan x? First you will have to create tan x, no, to put tan x equal to t. So here you can see, you can create. Achha, you might be thinking, sir, tan x, why tan x? Because if tan x is there in the numerator, denominator we have sec square x. That's why we need to create tan x. I hope you understood the meaning of it. Right? So sec square x minus 4. Abhi sec square x minus 4 in terms of tan you want to write. Sec square x minus 1 you know is tan square x. So tan square x minus 3 can I write directly? Right? This can be written as sec square x dx. Sec square x minus 1 is tan square x. Sec square x minus 1 minus 3 is sec square x minus 4. So tan square x minus 3. Correct. So tan square x minus 3. Now you know that tan x ka integral is sitting in the numerator. So without thinking, tan x you'll put as t. So sec square x dx will become dt. And you just have simple thing. Now dt by t square minus 3. 1 by a square minus b square. Correct. What will be created? This is going to become nothing but dt by t square minus root 3 whole square. This format, this is direct formula. 1 by 2 into a, 1 by 2 root 3 into log of t minus root 3 upon t plus root 3. 1 by 2 root 3 into log of t minus root 3 upon t plus root 3 plus c. Correct? T again you'll have to substitute. Put t as tan x again. So tan x minus root 3 upon tan x plus root 3 it will become plus c. 1 by 2 into log of 1 plus x upon 1 minus x. X plus a upon x minus a upon x plus a. Sorry. X minus a upon x plus a. Okay. Next thing, the b part. 1 by 9 sine square x plus 4 cos square x. Try to do it verbally once. Divide by cos square in the numerator and denominator. Divide by cos square in the numerator and denominator. Okay, let's do it over here. What will be created? 1 by 9, numerator will become sec square x. Denominator will become 9 tan square x plus 4. 9 tan 4 sine square x plus 4 cos square x is 1 only. So 9 tan square x plus 4 we'll have. Tan x, correct. Numerator will become sec square x dx. What will denominator become? Divide by cos square x. 9 tan square x plus 4. 9 tan square x plus 4. 9 tan square x plus 4 will be created. Correct? Again put tan x as t. Here put tan x as t and you'll be able to see the solution. So numerator will become dt. Denominator will become 9t square plus 4. So t square plus 2 by 3 whole square. It will become dt divided by t square plus 2 by 3 whole square. Right? Instead of writing 9x square plus a square, I am writing x square plus a by 9, a by 3 whole square. Correct? This format, you know. This will be 1 by, this will become 1 by 9 into 2 root 3 tan inverse of x by a. Tan inverse x by a. Directly you will be able to apply. So this is all about the formats. Please practice all the formats. Please do practice all the formats very carefully. It's all about the formats in entire integration chapter, nothing else. All the formats are covered. All the important formats are covered. If you think something is remaining from indefinite integration, then please remind me in the comments box. This thing was not there. I'll teach you that separately. But I think most of the formats which are going to be used in your mains or advanced also are covered. Right? Now it's about manipulation. Practice more and more problems, and when you practice a lot of problems, you'll come across these formats only. You'll be able to convert one thing given in the question in another format. NIT Parangal, I'll do advanced PYQs also separately. Please, I'm just one person and every day it's, you know, first make the take the questions PPT, then every day I'm not able to take the sessions because of some reasons also in my throat, but yeah, I'll try to create the frequency much higher now. Don't worry. Thank you so much, Magic of Moni. Everybody, good luck. Please prepare well, keep studying. See, there is just one chance. Either you work hard now and later you won't have to work that much hard. Later you can flaunt your skills and all. Working hard is there, but we don't have to keep on working hard, and amount earned should. Hard worker is a labor person also. He works so much hard, but how much he earns? Very less. What is periodicity? Periodicity in maths or in chemistry you're asking? Occurrence of powers in maths if you're asking about. Okay, so now I'm saying that either work hard now, a lot hard now, and later you'll work less and earn more. If you don't work hard now, later you'll work more and earn less. So choice is yours. Okay, keep on doing it. Rock it. Bye bye, take care, have fun. Thank you, thanks a lot. See you in the next session.